All right, this is actually take 2, y'all. I'm a little annoyed. I already did this video once and then went to check and somehow it didn't record. So Miss Harrison is not very happy right now. Anyway, that's my rant. I'm done. Okay, take 2. Gotta love technology. So we're going to continue on with quadrilaterals. We already talked about quadrilaterals a little yesterday. So now we're going to look at special quadrilaterals. Okay, so from yesterday we know any, that says any, the A got a little chopped off. Any four-sided polygon is a quad. We talked about them last week briefly too. So the first one that we're going to not talk a whole lot about is the trapezoid. Okay, and they did talk about it yesterday. But it is a quadrilateral. What makes it unique or special is that it only has one pair of parallel sides. Okay, one pair of parallel sides. And I think yesterday the video talked about having a king and a queen, and it had a prince and a princess. And this is like, you know, the black sheep cousin or something. It's just got one pair of parallel sides. Okay, that's the trapezoid. So what we're really going to focus more on are the other special types of quadrilaterals. The first one being the parallelogram. Okay. The parallelogram, the definition of a parallelogram is it's a quadrilateral with two pairs of parallel lines or sides. Okay. So the left runs parallel to the right side and the top runs parallel to the bottom. And so once you just know that, then you also can realize that, okay, everything we learned about parallel lines will come into play, if possible. Alternate interior angles, alternate exterior angles, corresponding angles, consecutive interior angles, which is really the only ones that you will really use, the consecutive interior angles. But yeah, remember when I said parallel lines? Not really ever going to go away. This is where you see that information pop back up too. So parallelogram has two pairs of parallel lines. Parallelogram also has some other stuff going on with it. Actually, let's flip to the back so you can see. So, and there's some vocab at the bottom I'll let you copy in a couple minutes. In a parallelogram, okay, the definition of a parallelogram is that opposite sides are parallel. That's what makes it a parallelogram. But also what you are going to see, there are a couple other facts about the parallelogram, and I think they touched briefly yesterday on them, but we're going to really kind of look at them, is that your opposite sides are also congruent. So your top is equal to your bottom, and your left side is equal to your right side. Opposite angles are also congruent. Okay, I'll show you what those look like in a second. Diagonals bisect each other. Okay, diagonals are the lines you can draw inside your shape from corner to opposite corner. They bisect each other. Bisect, if you forget, means cuts in half, so you might want to jot that word down right there. Bisect means cuts in half. Okay, so if the entire diagonal is 10, when they bisect each other, then the two smaller pieces will be 5 and 5. And the last thing about a parallelogram is your consecutive angles are supplementary. That comes from your parallel lines and the angle pairs that you get with parallel lines. Okay, so if you come back here and look at this shape, excuse me, we know that your opposite sides are parallel. They're also congruent. So just as an example, that means if this top piece is 12, then you know this top bottom piece is 12. If this left side was 5, then your right side is also 5. Inches, yards, whatever. And again, that will change, but that's just an example. The way we write it generically on our picture is we use our little tick marks. So this side is congruent to this side, and this side is congruent to this side. Your picture is going to start being super messy in just a second. We also heard that opposite angles are congruent. So your opposite angles, this and this, have the same measure. Okay, so if this angle was 130, then you know this angle is 130. Okay, could be a different number, but just as an example. The last thing that we know about let me mark these. These would also be opposite, sorry. There's two pairs of opposite angles. So if this angle down here at the bottom corner is 50, the top corner is 50. The other thing is the consecutive angles are supplementary, and this has to do because your lines are parallel. They're consecutive interior angles. So what that means is that this angle up here in the top corner, this one, and this one, those two add up to 180. Okay, as would these two, because consecutive means one right after the other. It also would mean these two right here and these two right here. Okay, so you have a lot of supplementaries going on there. All right, so that's a parallelogram. Now, there are special types of parallelograms. Okay, so right here, write special types of parallelograms. And again, talked about them a little yesterday. They have their own unique properties. And again, ran out of room, so we got a dash there. So the first one that we're going to talk about is a rhombus. Okay, a rhombus is a parallelogram. It meets the definition of a parallelogram. Okay, if you look at this rhombus, you should be able to clearly see that the left is parallel to the right, and the bottom runs parallel to the top. Okay, that is the definition of parallelogram. What makes it special, or what's unique about a rhombus, is your opposite sides are still congruent. Okay, so the top is still congruent to the bottom and the left is still congruent to the right. But what's special about a rhombus is that actually all four of your sides have the same measure. So all four of these are congruent. So if they tell you one side is 10, the other three sides are 10. That doesn't happen in just a parallelogram, but that's what makes a rhombus a rhombus. So, bounce back to your chart. I just said a rhombus is a special kind of parallelogram, so we know the first 5 properties apply. Okay. What makes a rhombus unique? Okay, we saw the first one happen. All your sides are congruent in a rhombus. Okay. Show you what this looks like in a second. Your diagonals bisect the angles, and your diagonals are perpendicular. So there's that word bisects again. I suggest that you write it down. Bisects, okay, cuts in half, perpendicular. If you forgot, form right angles. And then you might want to add supplementary in case, because we already talked about consecutive angles being supplementary. So bisects means cuts in half. Perpendicular means they form right angles, and supplementary means add to 180. So let's see. Okay. I'm only going to look at the diagonals bisect the angle and that they're perpendicular. So your diagonals do this. That's what your diagonals look like. What they mean by bisecting the angles is if your angle has a measure, okay, I'm going to make this bigger. This diagonal is going to split the corner, and it's going to make this piece, this little angle, and let me do a different color because I already used blue. That this angle is going to be equal to this angle. Okay, all the way around your shape. These green lines are going to cut these corner angles in half. So in other words, they may tell you, oh, this corner angle, this whole corner right here that I marked, well, let's do it down here. This whole corner right here is 40 degrees. Diagonals bisect would make this 20, and that's really hard to read. and this 20. That's what they mean by bisects. Okay. The other thing they talk about with your diagonals is in a rhombus, when your diagonals cross, so where your two diagonals intersect, right here, that's a 90-degree angle, that's a 90-degree angle, that's a 90-degree angle, and that's a 90-degree angle. They're perpendicular. So if they ever asked you for that angle there, you would say it's 90 degrees because diagonals are perpendicular. The next special parallelogram we're going to look at is the rectangle. The rectangle fits your definition for parallelogram because the top is parallel to the bottom and the left is parallel to the right. Okay. Now, what makes the rectangle unique is that a rectangle has 4 right angles. Okay. And again, you know this. This is not a new fact. So let's jump over to our chart and fill in the properties that go with a rectangle. Well, again, a rectangle is a special parallelogram. It's a parallelogram with 4 right angles. So first 5 still apply. But what is unique to the rectangle is all your angles are actually congruent because they're all 90 degrees. Those 4 corners are all 90. Also in a rectangle, if you notice, looking at the picture, it's not leaning. If you go back and look at your parallelogram and your rhombus, they lean to the side. Okay, they have a lean to them. Looks like they're kind of falling over. That is not the case with your rectangle. And when it's not leaning, then those diagonals that go through it are actually congruent. They're actually the same length. If you look at your rhombus, just as a you should be able to see that this diagonal right here is a little bit longer than this diagonal because of the lean. The same thing if you were to draw your diagonals in your parallelogram. You would see one is longer than the other. When we draw our diagonals in our rectangle, because it is not leaning, those are the same length. So they could tell you one, how this is 12 inches, you'll know the other one is 12 inches. Okay, so again, your angles are all congruent, diagonals are congruent. That's what makes the rectangle unique. Last one, okay, is the square. The square is as if your rhombus married your rectangle and they had a baby, and the baby gets genes from both. So the square gets the 4 right angles from the rectangle and the 4 congruent sides from the rhombus. Okay, and it is a parallelogram because if you look at that, the top would be parallel to the bottom, the left would be parallel to the right. Again, what makes it a square is you got 4 congruent sides and 4 right angles. Okay. Now, when we go over to our chart, we know a square is a special kind of parallelogram because it fits the definition. So check off the first 5. We also now see with the square that since it takes some of its stuff from the rectangle, all the angles are congruent because all 4 corners are 90, and my diagonals are congruent because, again, a square does not lean sideways. Okay, when you draw those diagonals in, they are going to be the same length. We also realize with our square is all our sides are congruent, just like the rhombus. It also means the diagonals are going to bisect the angles like it does in the rhombus, and it also means that the diagonals are going to be perpendicular like a rhombus. So the square has everything. Anything you can think of out of these properties works with the square. What you have to be careful of is what only works for a rectangle, which only works for a rhombus, okay, versus what only works for a parallelogram. Square is the easiest because anything you can think of works for the square. So you are going to want to kind of look this over and study it, make sure you get straight what goes with what. A lot of times you can tell if you understand the picture, but there are a few facts that you may not just be able to get from the picture. So let's see how this works out in actual problems. So I am looking at this picture And they don't specifically tell me, but I know it's not a rhombus. I know it's not a square. It could possibly be a rectangle, but I think it has a little lean to it. But either way, it shouldn't affect what I'm about to do. So I look, first thing you want to do is read the question, find the value of x. Okay, second thing you want to do is go look at your picture and figure out what is x representing. Is it a side? Is it an angle? Is it a diagonal? Is it part of a diagonal? And so I look, 3x minus 11, that's part of a diagonal. X plus 5, that is another part of a diagonal. So I know I'm going after something about a diagonal. Okay, here's where my chart comes in handy. I don't have these memorized yet, so I need to look. So I scan my properties for a parallelogram. Opposite sides parallel. Okay, they're not opposite sides. Opposite sides congruent, same thing, not opposite sides. Opposite angles congruent. I'm not looking at opposite angles. I'm looking at something with diagonals. Diagonals bisect each other. Oh. Remember, bisects means cuts in half, cuts it into two smaller equal parts. So I come back here and go, okay, well, I'm looking at 3x minus 11 being this part. I'm looking at x plus 5 being this part. Diagonals bisect each other means that this small piece is the same measure as the other piece of my diagonal. Okay. So I do the algebra, and I'm going to roll through this at this point. If you have questions on it, let me know. Subtract x from both sides. Add 11. Divide by 2. So x turns out to be 8. Woo! Now, they didn't ask, but they could possibly, because what you'll see is I'm not going to be able to give you every type of example of every type of question that they could possibly throw at you with this stuff, because there's so much. So just to show you, they didn't ask, but they could come back and say, hey, well, what does this piece actually measure? So what you would do if they asked you that, you'd come back and do, well, x is 8 plus 5, so this piece measures 13. They might ask you for this piece too. You wouldn't have to plug back in unless you really wanted to, because you know that they're equal. The diagonals bisect each other. So if you figured out this was 13 without plugging in, you would know that this piece is also 13. So again, just putting that out there because they may ask you something like that. All right, question 2. Find the value of x and y. So I look at my picture. Now, don't do this. Don't think that you're going to mash x and y and all of those numbers into one equation. You got to break it down into pieces. So I'm just going to focus on the x right now. I'm not worried about the y. So what I do is I come to my picture. I go, well, there's 3x plus 4. That is representing this, and I'm going to mark it. So that is clearly a side. So I need to use something I know about the sides. Go back to my chart. I need something about my sides that's going to help me write an equation. Opposite sides parallel. Okay, that's nice, but it's not going to help me write an equation. Opposite sides are congruent. Oh, congruent means they have the same measure / they're equal. So do I have opposite sides that I can work with? Well, there's my 3x plus 4. Well, yes, I do. Look, there's a 16. Those are opposite sides. So opposite sides congruent, 3x plus 4 equals 16. Congruent means they have the same measure, so I set them equal. Notice I didn't try to do anything with the y minus 16 and 56. Okay, notice I didn't try to use the angle with the side. Okay, you can't mix things. All right, do the algebra real quick. Subtract 4, that gives you 12. Divide by 3. 12 divided by 3 is 4. So x is 4. Woohoo! Again, if they asked you for this side, you could plug in, but if you were paying attention, you wouldn't have to plug in, because you would say, oh, well, if the left is 16, then I know the right is 16. Okay, the reason we had to write an equation, though, is because they asked us for x. All right, we also have to find y. So now I'm going to focus on y. So I come over, y minus 60. Okay, that's this right here. That is clearly an angle. So now I need to figure out what I know about angles. Come back to my chart. Not even going to bother to look at the first two properties because those are talking about sides. So opposite angles are congruent. Then I keep reading, consecutive angles are supplementary. Well, I do know I'm working with an angle. I got to go look and see what I got. Do I have opposite angles with information on them, or do I have consecutive? Well, I already marked this. Now I'm going to mark this. These are opposite angles. They are across from each other. So the opposite angles are congruent. Okay. That's from my chart. So I'm going to say y minus 60 equals 56. Opposite angles are congruent. Easy algebra. So y is 116. Woohoo! Now, they didn't ask you this. Well, they're going to ask you in the next question, so I'm not even going to show you this. But that 56 will also let you get this angle right here and this angle right here. Now, don't tell me that those are 56 because they're clearly not the same because those are obtuse angles. Okay, 56 is an acute angle. But what you need to remember is what you know about these two angles, or those two angles, which is what we're going to do in the next one. So, moving right along. So, again, find the value of x, read my question, cool. Come and look, okay, x is right here, we also have an x right here. Decide what you're looking at. Are you looking at sides? Are you looking at angles? Are you looking at diagonals? Oh, okay, those are angles. So let me see what I know about angles. You should know two things about angles. Opposite angles congruent, consecutive angles supplementary. Come back over here, go okay. Are these opposite angles? Are they consecutive angles? Hopefully you see they are one right after the other. These are consecutive angles. I'm abbreviating. Consecutive angles are supplementary. So that means they add up to 180. Remember I told you some vocab would never go away? Yep, here it is. Again, same thing. These are consecutive angles because your top is parallel to your bottom. And those are consecutive interior angles. And back when we talked about parallel lines, we learned consecutive interior angles add up to 180. Okay, that's why it's on our chart. So, if they add up to 180, I take the first angle, I add it to the second angle, and set it equal to 180. Luckily, this is easy peasy algebra. Divide by 9, so x is 20. Woo. Now, they didn't ask, but they could very well ask, well, what's the actual angle measure? What's this angle actually measure? So then you would go, oh, that's 5 times 20. That's what I got. So this is 100. They could also ask you for this, so that would be 4 times 20. That is 80. Okay. They could ask you for this angle over here. This angle right here. That would be 100. It's opposite. Opposite angles are congruent. They could ask for this angle right here. Okay. It would be 80. Opposite angles are congruent. Or you could say, oh, well, the 100 and this angle are consecutive, so they add up to 180. Either way. Okay. Just to throw that out there. All right. Moving right along, find the value of x and y. Again, I do not panic. I do not try to match everything into one question. I just go to x, mark, decide, sides, diagonals, angles. Clearly that's a side. Okay. You only know two things about the sides. Either they're parallel or they're congruent. Parallel will not help me write an equation. Opposite sides are congruent. Oh. X plus 2 equals 6. So x is 4. Now I attempt to look at what they want me to do for y. Again, I don't make any assumptions. I look where my y information is, mark it. Okay. Angles, sides, diagonals. That's a side. Opposite sides congruent. But again, some people get here and they try to put everything into one single equation. 9 times out of 10, that's not what you want to do. So I get y equals 21. Okay, cool. Just using my properties. All right, last one, just in the essence of time. Now, here's the thing about this one, and this is going to probably happen to you. And it happens. You have got to draw a picture. If you do not draw a picture, you cannot answer this question. And if you do answer, it's going to be wrong. You cannot do this if you don't have a visual. So, rectangle ABCD. Doesn't have to be a work of art, but please make it look like a rectangle. Oh, that was not very straight, was it? Don't draw me a square. Don't draw me a leaning parallelogram. Don't draw me a diamond. It said rectangle. Now, when you label it A, B, C, D, make sure you follow your shape. Do not go A and then jump down here and put a B right down here at this corner and then go up and put a D. Follow the shape. Otherwise, this is not going to work out well for you. So, triangle A, B, C, D. And again, I could have gone a different direction, but that's how I went. Diagonals AC and BD. So, I'm going to draw diagonals. Diagonals go corner to opposite corner through your shape. So there's diagonal AC, there's diagonal BD. Meet at point E, so where they cross right here is point E. Now they're going to give me some information that I'm going to write on my picture. Okay. Write it on your picture. If CB is 6, so CB is the bottom of my rectangle, and AB is 8, AB is the left side of my rectangle, and AC is 10. So this whole diagonal right here is 10. But I know in a rectangle, diagonals bisect each other because 10 is hard to write. If you write it here, then you might think from A to E is 10. If you write it here, you might think E to C is 10. It's hard to center the 10 in the correct spot to represent it's the whole segment. So I'm actually going to take it a step ahead. Diagonals bisect each other, so if the whole thing is 10, then I know A to E is 5 and E to C is 5. Just so I can put them on my picture and know exactly what part they go to. And then they want us to find AD, CD, AE, and DB. Okay, so I'm going to use what I know about rectangles. They're all sides or diagonals, so I'm just looking at that. I know opposite sides parallel. That's not helpful. I know opposite sides are congruent. That's probably going to be helpful. So I'm looking at AD. AD is opposite BC, so if BC is 6, AD is 6. Then I go look at CD. CD is my right side. CD is opposite AB. If AB is 8, CD is 8. Now, clearly I did not draw my rectangle properly because they're saying that my smaller sides are 8 and my longer sides are 6. That's just user error. It doesn't matter. Okay, we just say it's not drawn to scale. And then now they want AE. Now, because I already split my 10, I already know what AE is. AE is a diagonal. What do I know about diagonals? Diagonals bisect each other. So from A to C, the whole thing was 10. If I just went from A to E, that would be half of 10. That would be 5. They could have asked me for EC too. That would have been 5. They could have asked me for BD. They could have asked me for this whole diagonal. You would have said 10 because diagonals are congruent. They could have asked you for BE, just this piece right here from B to E. Well, 10 divided by 2 because the diagonals bisect each other. You would have gotten 5. They didn't. I'm just kind of throwing that out there because you may run into a question like that. They also want DB. Oh, they do want that. All right, so if you know that AC, this whole diagonal is 10 or 5 plus 5, then you know that DB, the other diagonal, is 5 plus 5 or 10 because diagonals are congruent in a rectangle. So lots of different things they could have asked us there. Key to this is mark what you're looking for. Decide if it sides. Are they sides? You're looking for a side, something that has to do with a side, an angle, or a diagonal. Go to your chart and find the information that you know about. So if you say I'm looking for an angle, then I'm going to go to my chart, scan it, and find the properties that talk about angles. Okay, and really honestly, there's only 2 choices with angles. 3, sorry. They're congruent, they add up to 180, or they're bisected. Okay, so like I said, I couldn't possibly give you every type of example of every type of problem that they may ask you because there's so many options that they could go with. So when you get to the work, make sure you have this chart. Okay, even if you just have a screenshot version of it, have it because you're going to need it. Make sure you have this. Don't just try to willy-nilly go in and do these problems because it will be a nightmare for you. But as you work, ask yourself what you got. Go to the chart, look up what you know about that particular thing, sides, angles, or diagonals, and see if you can go from there. If you get stuck, please let me know. I'll be glad to help you. We are going to be doing some office hours / Zoom sessions starting next week if they haven't already started. So make sure you're staying on top of that. If you need help, reach out to me. All right, y'all. Thanks for watching.